Hi guys, as you know, Nick Rice from First 5 Minutes, and we're just going to do today, we're going to talk about thermal detectors. Last week we spoke about smoke detectors. This week we're going to talk about thermal detectors. But before I start, I'd like you to cast your mind back just to a week before last week when we spoke about fire resistance levels, fire doors, firewalls, etc. and the importance of keeping fire doors closed and latched shut, with the smoke seals always in good condition to stop the toxic fumes and smoke entering those compartments. Now, quite ironically, I saw on LinkedIn a few days ago an arson attack in a block of flats or apartments in Yorkshire in the UK. And this is just showing you an example how fire doors work and the importance of keeping them closed. Can you see that?
It hasn't opened.
Hasn't opened, right?
No.
Yeah, and I'll open up. So you've got that one?
Yep.
So you see this is charring of a door. There's a door there. That's actually a fire door on that side. I'll start the video and I'll pause it there. If you see, that's a fire door. Okay, and that's well charged. That's probably a 2-hour rated fire door, I should imagine. And you see inside the apartment, it's been hardly touched. You look down the corridor where this arson attack was taking place. I don't know what the accelerant was, but it looks to me probably like something like petrol, the state of it. So down the corridor there, it's all burnt, and that door was shut and that's shut. And you can see there's hardly any damage or any at all to the room itself. So that's just showing you the importance of firewalls and fire doors. So today, as I say, you can see that.
Yep.
We're going to just talk about active systems, still thermal detectors. So you've got different types of detectors. You've got thermal heat detectors, you've got rate of rise and fixed temperature. You've also got flame detectors, which are ultraviolet, infrared, and UV IR combined. We'll just tell you about the use list and the photos, and obviously some photos of them. So thermal detectors are classified as a rate of rise and fixed temperature. Now, these are the main type of temperatures, main type of detectors that you're going to see in your everyday buildings. So the rate of rise detectors are designed to detect a rapid rate of rise of more than 10 degrees C over a minute. These are known as electropneumatic detectors. Fixed temperature ones generate an alarm at a particular threshold, and they're used by bimetallic strips, and bimetallic strips are like 2 strips of metal, one being copper, one being mild steel. They're both glued together. Copper expands faster than the mild steel, pushes it over, and cock makes the contact. And I'll show you those now with these working principles I've got here. So in normal conditions, the thermal rate of rise detector, which remember detects the rate of rise of more than 10 degrees over a minute, will expand. This chamber expands. You see there's a contact there, excuse me, contact there which is open, and it gets hotter. There you are, bang, closes the contact, and that then generates a signal back to the fire indicator panel, which then the fire indicator panel starts BMS systems, smoke management systems, all that type of stuff, shuts fire doors a lot. So that's a rate of rise detector. A fixed temperature, as I said, was 2 metal strips called bimetallic strips. One, I think, is copper and the other's mild steel. Copper expands quite quickly, so it bends that steel over. And this side here, you would have a contact. So that would be a fixed temperature. So it would have been worked out, right, what temperature, right, 68 degrees, and that will then make the contact there. And I think it's just a matter of moving the contacts. So here you've got the 3 different types of detectors. You've got the rate of rise detector here. Sorry, fixed temperature, rate of rise here, fixed temperature here. and you've got a smoke temperature, the smoke detector, and a fixed temperature thermal detector here. Both of these can be used for if you need two inputs. So you might get one input, which is smoke, which will unlock a gate to start a gas deluge system, for example. And if it detects heat, then it will open the gate and it deluge gas. So it's got two detectors in one. So thermal detectors, area of usage, because you need them in high dust context. No use putting your smoke detectors there, because all your smoke detectors do is pick up unburnt products of combustion. Dust could be classed as unburnt products of dust combustion. Gets in the way of those electromagnetic beams, bang, and you've got false alarms. So using train stations, aircraft hangars, outside bathrooms, in kitchens. You got these ones, flame detectors. You've got UV detector that detects UV. The disadvantages are respond to long range, like welding, lightning strikes, all that type of stuff, because they pick up the UV. So you get a lightning strike, and it's going to pick up the UV signature and set the alarm off. So it can be quite a few false alarms here. IR detectors, they're prone to false alarms as well, because they pick up the infrared emitted from flames and things, but they can also get it from lights and what have you. But you've got this other one here, which is a UV IR detector, and you can have them a combination. So it's got to pick up a UV signature and an IR signature to be able to set an alarm off. Sometimes they're not set that way, but more than likely they would be. And they're usually used in places like industrial warehouses, chemical stores, production places, underground tunnels, motor test beds, anywhere which you wouldn't put a normal bog standard smoke or thermal detector. But if you put a normal thermal smoke detector in places like that, they're not going to work at all, especially in places like industrial warehouses where you've got lots of dust, chemical production plants, underground tunnels, you've got lots of dust, so a smoke detector would be going off all the time. And here you've got some YouTube links to take you to how these detectors work, either UV, IR, or the normal thermal detectors, being the rate of rise or the fixed temperature type. Have you got any questions, anyone? No? Good. So next week, what we'll talk about, probably be Thursday next week, different types of sprinklers, how they work, color coding sprinklers, fast response sprinklers, and sprinkler systems. So you have sprinkler systems, for example, in freezers. Most sprinkler systems have got water inside them. So of course, if they go in freezers, they're going to freeze up. So how are we going to get over that? So I'll just let you know. And then obviously there's some links.